So our presenter for tonight, or sorry, for this afternoon is Sir John Elmer Loretizo. So actually, he has a degree in BS Software Engineering from Central Philippine University and Masters in Business Analytics from the University of California, Davis. So he just finished his master's this year. So he specializes on computational science, especially data science and algorithm. So for this afternoon, he'll be talking about data gathering and analysis. So, Sir John Elmer.
Yeah. Yeah, thanks, John. Yeah, currently I do work as a data scientist for a tech firm around the Bay Area. And yeah, I will be talking about data gathering and analysis. And as I've mentioned a while ago, this discussion would generally be kind of like more of an open floor discussion. So at any point or like at some point in the slides, I would stop in and ask if from you guys if you have any questions or do you have any points of clarification to make. Um, yeah, so let's just go ahead and move forward. So first off, like the general question and the broadest question that we always get is like, what do we even mean by gathering data? You know, it's very, if you think about it, it's kind of like very mundane. Like, yeah, we just gather data, we just take note of them. But if you take a deeper look at it, it's not just that. You know, there are a lot of different questions that you need to answer with gathering data. Are you gathering the right data? Is it the point of interest for your research? What kind of data are you collecting? Is it accurate? Are you even doing the measurements in the correct way or form? So when we say we're gathering data, it's just a general process of collecting observations or measurements relevant to your research. So let's say you're doing plant research or let's say a general survey of a user base from a website, then are you collecting the right metrics? Are you collecting the most relevant set of observations? Let's say Facebook groups. Are you are you gathering like the clicks or the responses to a picture, maybe the number of likes, the number of hearts? Um, so whatever is relevant to your research, that's probably the kind of data that you're very interested at, and it's part of the data gathering process. Next is it may also be in the form of like just identifying variables of interest and defining levels of measurement. So what do we mean by defining levels of measurement? Sometimes data comes in many forms. Like there are text data, there are images. It's not now like a black and white, just numbers kind of data. You would sometimes have to deal with these images and this what we call as qualitative forms of data. And what you want to define as like the level of measurement is one, how deep of the granular information are you trying to get. Let's say you're looking at a picture of a flower, like what kind of observation do you want to take from that picture? The color. Do you want to, let's say, also take note of the breed or like um, the origin of the flower? Let's say if you have a very clear picture, how many petals does it have, whatnot. So those are the levels of measurement. The granularity of your data is something that is also part of your data gathering process. Next is, and probably the most important one, is that when you're in the gathering of data or in the process of doing one, you always want to ensure that your data is accurate or is precise to a certain extent. And again, like in any form or shape, like garbage in, garbage out is always what we say. So if you gathered the wrong data, you would obviously come to the wrong conclusion and maybe like get like the wrong set of inference from your research. Um, Next, What kind of data do we expect to get? So there are two main types of data that you would usually expect to get. Quantitative data, which means those data are usually expressed in numbers, let's say height, sound levels, or ranks. And then qualitative data, usually these are the forms of data that's not directly expressed as numbers, but are actually expressed in other forms. So it may be like a sense of feeling. So are you feeling warm? Are you feeling cold? That can be a form of data. Images or appearance. So let's say you're looking at a street view. What's the signal light directing at? Is it green? Is it red? Is it yellow? How many cars are around the vicinity? Is there a pedestrian? Is it an intersection? Is there a stop sign? Whatnot. So those are kinds of data. These are images, but there's still a form of data that you would get. Another form that's becoming very, very common nowadays are texts and narratives, and even recorded messages, let's say. Um, these are the ones that you see everywhere. Facebook would have them, text and narratives, your posts, Twitter, news information. These are all forms of data. So usually the key factor that differentiates quantitative apart from the numbers themselves, qualitative data is usually unstructured. What do we mean by unstructured? It's kind of like very raw. Data in itself is already raw, but qualitative data has that another level of being raw to itself that you need to actually extract more information from it to actually kind of like make sense of the patterns that are in the data. So that's another aspect that kind of like differentiates these two. Next question is, in terms of the data collection, like how do we do that? What tools do we actually employ, or what techniques do we have? So probably in your books and in research, general research, this 6 bullet points would have been the things that you would see: interviews, questionnaires or surveys, observations, documents and records, focus groups, oral history. But another thing that's also becoming very common nowadays, now in terms of data, the data collection process is the app usage, or social media usage, or even just regular everyday usage of like taking a train, whatnot. So any form of usage now is becoming like an implicit form of data collection. So if you're using your phone, for sure your mobile app that you're using, Facebook, Twitter, Instagram, would collect data from you. Let's say you're taking a public transit, the public transit that you're in would collect data from you. Let's say you're taking an airplane, Cebu Pacific or Philippine Airlines, they would implicitly collect data from you. So how much you spent for that airline ticket, what seat you're seated in, maybe let's say what time you checked in, what time you arrive in the airport, maybe like some form of all of those data. So those are implicit forms of data collection nowadays that's actually becoming more and more common. It's actually very common. Um, and yeah, most of the data actually comes from these implicit forms of data collection. So the next part of this discussion is, yes, data collection is there. And to some extent, if you see the 6 bullet points here, it's very direct, right? It's just that taking this information. But the next question is, at the end of the day, if you're conducting a research, let's say, you can't collect data from everything, or like from the entire population that you're interested at. Let's say you're trying to create a treatment for, let's say, a certain fungal disease on a certain plant, or yeah, let's say a banana fungal disease on a banana plant. You can't experiment or conduct your experiment to all the banana plants out there. Obviously you'd have to take a sample, and I think John in his previous one of the mentor series that he had, he mentioned theories, he also mentioned how we design the experiments. So these experiments are actually just samples of the actual population. And this is where this sampling process comes in. Apart from having that good experimental design is actually ensuring that whatever samples you have in your experimental design is actually a proper representation of your population. So there are three key terms here. The first term is the population. So it refers to the entire group of people, events, or things of interest for the researcher. As I was talking a while ago, we're talking about, let's say, trying to find a treatment for a fungal disease in this banana plant. So the entire population that we have is all banana plants in all of the world, let's say, or in all of the Philippines. However, we cannot conduct our experiment or research in all of those banana plants. What we want to do is we want to have a specific experimental design with a set of samples in it that actually tries to represent the full population of banana plants in the Philippines. Let's say there are different breeds of banana plants, and then there's a different, like maybe a weather factor. So that's what you want to put in your sample. So the sample is just a subset or a representation of your population. Now, the third key term here is the sampling frame. So what is it? Is just the list of the population elements from which the sample is drawn. So now you have this full list of, let's say, all your different banana breeds that you're trying to study at, and then you kind of like take from that list. So that list is the sampling frame. So the full list in itself as a whole becomes your full population. And from that list where you take, it becomes now your sample. So moving forward, the next aspect now is how do we actually sample, and how many samples is enough or is sufficient for us? So there are key factors. There are several factors, and I would answer the second question first. There are several factors when actually selecting the sample size. The first one is the variability of the target population. So variability, we mean here like how diverse or how many different kinds, so let's say of banana, or like how many different species do you see for banana. So the more variable it is, probably the higher the sample size that you want to get. Next is the degree of precision. Close and open parenthesis, the confidence interval. So what we mean by that is, let's say we found a treatment A for this disease. The degree of precision that we compute out of that is how big of, let's say it's between 90 to 99%. So that's the confidence interval that we're confident that this treatment would actually be able to treat the disease on the banana plant. So you want to be able to achieve a specific like range of values that you're actually confident enough to say that your research is actually valid and significant enough. Obviously, you don't want to, let's say, have a degree of precision that's between 50 to 90%. So your treatment can be 50% effective or 90% effective. You don't want that. So you want a smaller band, a narrower band, but you're more confident in that. So that's what we mean by the degree of precision. Next is acceptable risk in predicting the level of precision. So now there is this level of confidence also that comes with the confidence interval that you're computing. So out of, let's say, if you replicate your experiment 100 times, 95% of the time, the effectivity would be between 80 to 90%. So that 95% of the time is actually your confidence level. So if you do your experiment 100 times, if you're 95% confident, you would see that the confidence interval of 80 to 90% effectivity of your treatment, that's actually like the confidence level. So that's the acceptable risk that you're taking. So 5 out of 100 times, the effectivity might not be between 80 to 90%. It might be lesser than that, or who knows, it might be more than the 90%. And obviously, the last one is more of like a practical reason. So the cost and time constraint. Obviously, bigger populations, you would require more more cost to conduct the experiment, and obviously more time for it. So now, how do we do the sampling? So there are two main sampling designs that we can consider. The first one is probability sampling, and then the second one is non-probability sampling. For most research that's very rigorous, you would want a probability sampling kind of sampling design. So every element has a known chance of being sampled, and representativeness is important. So let's say I more users from country A against country B. So that's a form of sampling wherein you want a proportionate sample from country A against country B. So I've listed here three simple probability sampling. So simple random sampling, you just say that, let's say you have 10 different, let's say you have 100, sorry, 100 elements on your population. Each one would have an equal opportunity to be sampled. That's a simple random sampling. If you're conducting a systematic sampling, let's say for every nth element that comes in, you sample it. That's kind of like, that's a systematic sampling. The stratified sampling is one that's similar to this country A, country B analogy that we have. So wherever there are more users, you would sample more from them, and wherever there is less, you would sample lesser from them. So from, let's say, 100 country A and then 50 from country B. So that's kind of like, you would want to sample twice as many for country A as opposed to that of country B. So that's stratified sampling. Now, non-probability sampling also exists. And it's more of like, it happens more on like marketing terms. So convenience sampling, purposive sampling, and quota sampling. Convenience sampling is just simply like whoever is an available person to actually answer a survey, you would just sample from them. You would not have like a specific set of criteria to actually sample. Quota sampling is just like when you have like when you're trying to reach a certain number for a specific number for a specific criteria. That's a form of a quota sampling. And then purposive sampling is obviously like you're coming in with a purpose of you like probably selecting a specific set of people. So that's a purposive sampling. So now, probably like at this point, the question that you guys would have is like, how is this all tied up with the data gathering process? And the simple answer for that is, if you don't sample correctly, let alone do a correct experimental design, the data that you would still collect is not valid or is not accurate enough to actually, for you to actually say that your experiment is valid or is concrete or has sufficient evidence to prove something. So that's why we're kind of like discussing how we sample as part of the data gathering process. And the last part in this data gathering aspect is actually the data itself. What should the data be? Like, what are the characteristics of quality data? So the first one is accuracy and precision. What we mean by that is pretty straightforward. We want to be able to see data that's actually repeated in a way that, let's say you have multiple replicates for your experiment, you would see that they lie at around the same region. So your reading would be between, let's say, 5, 5, 5, and then 6. So your data is very precise. And let's say that you actually expect this reading to be 6, then you're also close to the most accurate or the most correct value, which is 6. Now, if let's say when you collect data and you collect 555 and then you collected a negative 5, so there is a discrepancy in your data because the three first values were 5, 5, and 5. So they're all precise in that area, but the last one might not be, or is not actually, because it's negative 5 and you're expecting your actual data to be around the range of 5 or 6. So that's the accuracy and precision, legitimacy and validity. So when you collect the data, are you collecting it in a legitimate way, or are you just trying to collect it without, let's say, an explicit permission from the user if you're conducting a survey? Validity is where is it coming from? So like, did you collect it or did you just make it out of the air? So like, that's very critical criteria. Timeliness and relevance, of course, is another thing. So you don't want data that's like 1 year old, or you don't want a certain data that's actually not relevant to your research. Reliability and consistency. So we can do research in a rigid manner because we want other researchers to be able to replicate our research. So this is where that fourth point comes in. Let's say I did a research and then John conducts the same research. When he gathers the same data, is he collecting almost the same set of data that I collected when I conducted it? That's the reliability and consistency aspect of your data. Like, let's say on general terms, marketing, for example, we know that we're gathering click-through rates, or like how often you clicked on an ad. And we know that in general, there's just a 1% click-through rate for a specific ad. If another company conducts the same marketing campaign for that's like a similar ad, they should also expect almost the same 1% click-through rate. So that just validates that your data is reliable and consistent because you could just easily replicate your research. Granularity and uniqueness. So this part just says like how detailed do you want your data to be and how different it is from, let's say, whatever open data that's available out there. Availability and accessibility, this is related to the second point. Um, it's very gray that some data is only available for some people. So you want data that's, when you're conducting a research, that you can actually freely share and that is easily accessible, because that also bolsters the legitimacy and the accuracy and the credibility of your research. So you don't want to seclude or cover up any data in your research because that just puts so much question. That's why a key aspect of like the quality data is also you being able to freely publish it or make it available or accessible to everyone. And the last one is like completeness and comprehensiveness. So in this aspect, you just want to be able to have like the most thorough set of data. And again, it's always a garbage in, garbage out perspective. If you collected or measured data in a wrong way, then maybe you're not gonna arrive in the most accurate set of conclusions and recommendations for your research. Yeah, so before I proceed, I would open the floor for any question. If somebody has a question or,
Okay, guys, do you have question at this point for in terms of data gathering?
yeah, may it be very specific to your team, may it be just like the broad data gathering aspect.
I have a question probably, but this is probably related to some of the students. So if they are conducting a qualitative research, is there a way that they can gather a data that might somehow be like in that they can present somehow in a quantitative manner, for example?
Right. Yeah. Um, I'll take the banana sample because that's what that's actually my high school research.
Mhm,
Um, During my time, one of the key data that was trying to gather is the look of the leaves of the banana plant.
mhm,
It's basically like a wilt score, like how wilted the leaves are. Um, Usually, prior research would give you like a scale. Let's say a 1 to 5. On a 1 to 5 scale, they would give you specific set of descriptions. 5 is like very worst wilting, so there's nothing left on the leaf itself. 1 may be like a minor spot of wilting. 2 may be like 2 or 3 spots, whatnot. So they prior research, and maybe within your team you would want to kind of like define this different levels, so this 1, 2, 3, 4, 5. So what qualifies as a 1, what qualifies as a 2, what qualifies as a 3, what qualifies as a 4, and so on. In that way, the qualitative aspect of like just looking at the banana leaf and the wilting, you converted it to an actually a number, which is a scale of a 1 to 5. 1 being the least wilting, and then 5 being like the full leaf has wilted. So something like that. Yeah.
okay.
So that's one form. So yeah, the quick answer is if there's no prior research that actually tries to assess a specific thing in your research, you as a team can actually try to define something that makes the most sense in terms of converting a qualitative to a quantitative data. If there is a prior scale that was used on a previous research, you might want to use that because that would kind of like help um, provide like legitimacy of your research, and the other aspect also is because a previous research has done it, it just makes it more of like a standard for everyone. You don't want to obviously alter what's already in there in terms of like the scales that they provided, so you could just use whatever that's there. So that's just my suggestion, or that's my opinion for that one.
Okay, thank you. So, do you have more question, guys, or do you want to proceed?
Hello po, tatanong lang din po ako. For example po, if you are measuring the accuracy of a device po. For example, if like successful po yung pag pag-me-measure niyo po ng temperature, yung pong karaniwan pong ginagawa po sa sa'min, it's like ilalagay po ay 1 if successful na po, yun lang po talaga yung nakalagay, and 0 po if not. Paano po kaya yun, like,
Right.
in between po siya sa yun po,
Sorry, hindi ko nakuha yung last, yung paano yung in between. What do you mean?
sige po. Like, kunwari po if you are measuring the temperature itself, paano po
Uh-huh.
kapag nasa gitna lang po yung na-measure po niyo and yung pong sa consider po ba siya as hindi na po successful if yung hindi po sana magiging successful, eh, yung, hindi po talaga accurate, like mababa pa po dun sa inaasahan, yun po.
So the process is to just measure the temperature, right? And then if it comes to like a certain level, you would say that it's measured correctly. If it doesn't go, if
Opo,
it doesn't reach that certain level, then it's a zero, something like that. So
opo,
parang
like meron
success fail.
Opo, like meron lang pong pagbabasihan na ginagamit na po talagang pang-measure ng temperature, and if yung nagawa niyo pong sensor ay katulad lang din po ng accuracy noong available na po sa dun
Right,
yung
right.
available.
Yeah. So yeah, good question. It's part. It's kind of like jumping in sa data analysis part. But actually, what you guys can do is to just measure number of false positive rates and the true positive rates. So there's a thing called confusion matrix. So it's just true positives. Wait, sorry. On there are four quadrants. So let's just visualize the four quadrants. Sorry. The upper right quadrant, we can put that as what you measured based on your device, and then what's the actual. So is it correct on your device, and is it the correct one? So that's the true positive. Um, there is also a true negative. So let's say hindi talaga umabot yung temperature, it should be like 0 and 0, then that's a true negative. And then what you guys would be concerned of is, in terms of accuracy, is how many times did your device not correctly measure the right temperature. So that's what we call a false negative rate, which means that it did not successfully measure, but it should have been a positive measurement. Kuha ba? Like, let's
Opo,
say,
opo.
yung measurement mo, you'll do the measurement 100 times. Or like, let's say 10 times. Sa 10 beses na ginawa mo yung measurement mo, there are 3 times na nag-fail yung measurement because yung device mo is hindi umabot dun sa desired threshold mo. So your failure rate is 3 out of 10. So basically, 3 out of the 10 times that you measured it, or 30% of the time, baka hindi magbigay ng correct measurement yung device na ginawa mo. That's just basically like the interpretation. So the temperature itself is not the data, right? The final data that you're actually collecting is the 1 and the 0. Tama ba?
Opo, opo.
Yeah.
Okay.
Also, although I would want to like just add on to that, you can still use the temperature data and actually compare what's the actual and what's the measured one, and then see if there's a significant difference. So it's not always like nothing in the world is actually a gray 1 or 0. It's always a spectrum of between a 0 and a 1. So maybe a better metric is to actually get the actual temperatures themselves and then see if, let's say, your device measured 37 and then you would expect 39 based on like the market device. So is the 2 degrees, is it significantly different or not? So that's a form of a statistical test that you would conduct. So out of all your samples, let's say you measured 10 samples, you have a control from your actual device, market device, an off-the-market device. And then you measure from your samples, and then you compare it with that one. So the mean temperature, let's say, is 37 for your device and then 39 for the market one. So is this 2% significant or not? That probably might be a better question to ponder. I don't know. Like, I'm not really read into the research, so those are just my thoughts for this one.
Thank you po, sir.
Yeah. Okay. Any more questions?
Hello po. Bale may question po ako. 'Di ba po, maganda po kung accurate po talaga yung data na makukuha. Meron po bang minimum
Right.
number of trials or ilang beses niyo po itetest yung ilang beses niyo po gagawin yung test sa device na yun para maging accurate
Right.
po yung numbers?
Right. Most common answer is the more, the better. The other aspect also is when you replicate your research, or sorry, when you replicate your measurement, you would come to a point when it kind of like converges to a certain value, or like it converges to a certain pattern or trend. So let's say initially gumawa ka lang ng 5 measurements. And then sa 5 measurements mo, it's not super precise. Merong 36, merong 39, merong 38, merong 37, merong 36 ulit. Tapos, yung actuals mo dapat nasa 37, 38 lang. Ngayon, pag i-repeat mo pa yung experiment mo, you would see it would converge more on a certain number. Let's say 37, 38, 37, 38, or 38 and then 36 maybe. So it would converge on that certain number. So as soon as you hit a certain confidence or like a certain like as soon as you hit that certain confidence in terms of like baka pag i-repeat ko to, it's still the same number, then I do not need to repeat it. It's basically like when you reach a certain confidence level or that just says that it's already significant. So yeah, dun ka lang hihinto. But the simplest answer maybe is the more the better, but obviously you can't do it forever also. So what you want to do is to set a confidence level. So from 100, let's say 50 tries, 95% confidence level, what's the reading? What's the confidence interval that we're seeing? So if you're satisfied with the confidence interval, if it makes sense, then okay. If it doesn't make sense, then maybe you should test more. Nasagot ba?
Opo, thank you po.
Or hindi klaro?
Okay naman po. Thank you po.
Okay, yeah. So yeah, just to like flesh it out to be clear more, you start with a certain number, 50, set a confidence level. You want a 95% confidence. So I do 50 now, but I want to be 95% confident that the values would be within this range. So the range is your confidence interval. So from the 50, you compute the average, you get the confidence interval at 95% confidence level. And then does that range, does that, like, let's say 36 to 38 range, does that make sense for you guys? Is it something that you can live on? If not, then maybe you want to test more. And if you test more and you see the same values, the same 36 to 38, then maybe it's about the device that you need to improve. Okay. Cool. Any more questions?
Okay, so I think we can move now to the next part of the presentation, I think, while they're still probably
Yeah.
thinking for other questions later.
Yeah. Okay. Cool. Next. So a part of like a majority of the questions now, I think has already jumped to like the data analysis part. Once we've ensured that there is a clean data, there's a data that we can really work on, we do the data analysis part. And again, this research, this presentation, I mean, I did not like put a detailed in-depth of like every single statistical test and data analysis that there is to do, because that would take us a day or more. But data analysis is generally just a process of transforming data into information. Data is raw. That's one thing that we need to understand. Data is raw. You're never gonna take anything really significant or really meaningful from it. So data analysis is the bridge between making something that's data or something that's raw into an information, into something that's digestible, something that we can derive a conclusion from. Now, there are different tools for data analysis. The most common one and the thing that we love the most maybe is Excel. Nowadays, data is so big, we want some form of like automation. We use Python. And I think for general research, R is really the language to go. And I would definitely suggest, if you guys haven't heard of R or haven't used it before, try it, it will definitely change the way you look at data and the way you try to perform your data analysis. It's basically everything is there. Maybe before we compute ANOVA in Excel, now we could just like do one line of code in R and everything is just computed for us. The last tool for data analysis, obviously it's not all about just crunching the numbers. Sometimes you also want to tell meaningful stories from visualizations. So we could use Tableau or maybe Excel charts also. So this is the last tool. So there are just those common things, and I'll just skim through this. There's the mean, median, mode, central tendency, and then there's the measures of spread. We have the range, standard deviation, and variance. And then we have also measures of association. So if one variable is increasing, does the other variable also increase or does it decrease? That's a correlation. And the other aspect is a covariance. So more often than not, you would encounter correlation. Covariance is like less used nowadays. And correlation is a derivative of covariance. So it's correlation is basically very, very robust. The other aspect for data analysis is the charts, the graphs. I've listed some here. I've shown an example on the right side. So this is just a Tableau dashboard where you would see a lot of different information from the data. So we could see here total cases in the Philippines, how many are active cases, how many have died, how many have recovered. And then we can see from these 3 histograms here, like how many cases are there in each day, and so on and so forth. So data visualization is really key for your data analysis. And maybe some things that are not all too common. One is a funnel chart. So it's very common in marketing. If let's say we sent an ad, how many was sent, how many was viewed, clicked, and then add to cart, and then like purchased. And then the other common, like the other not so common thing, sorry, is the heat map. So this one that you're seeing is actually, I think it's crime rates around DC area, I think. Yeah. So now this is where a bulk of the research comes in, the statistical tests. I decided not to like discuss them one by one because each one has their own use and each one would like entail a thorough discussion. So I would just scrub through them. So there are 2 main types of tests: parametric tests and non-parametric tests. Parametric tests, usually they make an assumption that the population is coming from a specific population distribution. And more often than not, the general assumption is that all our data that we gather, it follows this general bell curve shape. So bell curve or normal distribution, that means that, just the shape of the bell. Majority of your observation would fall on this like center line. This like the most common observation would be in the middle, which is like the bulk of your observation. So this is where the parametric tests are coming from. The non-parametric tests, they're actually distribution-free tests. I will not discuss them in thorough, but every parametric test, I believe, would have an equivalent non-parametric test, as far as I know it. As far as I have gone through them. So we have a paired t-test, we have a one-way ANOVA, we have independent samples t-test, Pearson R correlation. Now, the most common question that we have in terms of conducting a research is, what test should I conduct on my data? And the most common answer there is, what's your hypothesis and what are you trying to prove? I've seen a lot of research before that would only use a one-way ANOVA or a two-way ANOVA because that's what we do. But now there are a lot of different things that we kind of like hypothesize. One is, are my treatments different from one another? Like, is their effect on the disease, or let's say the disease different, significantly different from each other. So let's say I have treatment A, B, C, D. Are they different from one? Are they significantly different from each other? That's actually a two-keys test. That's not even listed here. Let's say a paired t-test. I get my weight now, I do a specific treatment plan or like an eating plan, and then I get my weight after. That's a paired t-test. So there's a before and then there's an after. Independent samples t-test usually is, let's say, is the mean salary of this set of people significantly different from this set of people. That's an independent samples t-test. A one-way ANOVA is actually just a better version of a t-test. It's just that if you have multiple replicates and all, you use an analysis of variance. Pearson R correlation is just basically like, is this variable, if it's moving positively, is this other variable moving more positive? So the gist is understand what you're trying to answer on your hypothesis. At some point or the other, if you just query the question of your hypothesis, you would actually get the parametric test that's actually needed for that. That's why I did not try to like discuss each one like in detail, because I feel like every single research would have their own quirks and nuances. Yeah, I think that's it for the data analysis. What I would be happy to answer now, or like to take in more questions, is like what, like in terms of your data analysis, what test might be important or whatnot. Yeah, just feel free to chime in for questions.
Okay, guys, you have questions for John Elmer? Like especially those of you that actually has data now, maybe you can ask for
Yeah.
for what type of analysis you have. I mean, you have to do for your data that you have. I have a medyo silly question. So you've mentioned that it's really actually important to know the objective and the hypothesis of your study, right? And basically probably even
Right.
the experimental design. But given that a lot of softwares are like um, they have easy interface now, that the options are you can just click and then
Right. Right.
so is it advisable to run every test available that you know every test available in the
Got you.
software?
Got you. Got you. Got you. Yeah. 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 Um, the answer is no. As much as you can, yes, you can do it. Nobody would stop you from doing it. Um, how do I put this? Sometimes us as researchers, we have this tendency of like, yes, I have this hypothesis, and I really want to prove it. So at the end of the day, you would see this in the in research field in general. Like it's not in general. Like there's like a very handful of people of exception that would just put in a specific test, even if it's not the most accurate test or the most appropriate test for this research, just to prove that the hypothesis is correct. So the answer there is like no, like just please feel free, please have the diligence to understand what you're trying to prove in your research. And because that's kind of like a neglect on your part, if you don't like understand, and like if you don't understand what you're trying to do in your research, and you're just like pulling a random test because that's the test that actually gave you a p-value that's significant.
That
um
is true.
that's what yeah, this is not like an unheard of situation Some researchers, like there's like very handful of people, like very selected maybe, they would just say that, oh, I did an independent samples t-test where I should have done, let's say, a paired t-test, because my independent sample t-test, the p-value was very, very low. Like it was like 0.00 something. And it was very significant. Like I have all the confidence in the world that my hypothesis is actually right. But when we saw the paired t-test, it's actually not right. It's actually not correct. Or the test should have been a different test altogether. It should have been like a two keys or whatnot. You know?
Yeah.
So that's like a grave mistake on our end, and that kind of like just
Mhm.
stains like general like the research in itself. Yeah, sorry,
Yeah.
go ahead, John.
So basically it boils down to you should know your objective, you should know your
Yeah,
hypothesis, and you
yeah.
clearly thought of everything.
Yeah,
Mhm.
correct. Yeah. And I feel like the other thing that would actually also help you is like if you know the experiment, if you did your experimental design,
Mhm.
like these tests actually would like easily, like if you search for examples on the internet, you would kind of like see a pattern of experimental designs being conducted on a specific test altogether. You know, like paired t-tests, you would see experimental designs where they have a pre a pre-treatment measurement and then a post-treatment measurement, and then you're just like, oh, is my treatment effective enough? So what you want to prove is that is it significantly, if your post-treatment measurement is significantly different from your pre-treatment measurement. So those kinds of experimental design, they usually tend to fall under a certain test. That's what I was trying to point out. Like the experimental designs, to some degree, they will eventually fall to a certain bucket of tests that you can conduct.
Yeah. Actually, that is true because some of the softwares, especially if you use SAS and other softwares, they will actually
Yeah,
ask, "What is your experimental design?" Actually,
experimental design,
and
right?
then
Yeah.
some of the tests will not be available for that kind of uh, experimental
Yes.
design. Actually, so yeah, everything is like really important, and when you do the analysis,
Yeah.
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 So, guys, you have more questions for John Elmer? Like, let's take this opportunity to like really ask questions.
Hello po, tatanong lang din po ulit ako. For example po, if yung goal po nyo ay malaman po if nakakaapekto po yung kunwari po ulit kanina sa temperature, kung makakaapekto po yung distance ng mini-measure nyo dun sa accuracy po ng temperature. Kunwari po, if malayo, less accurate po yung data. Ano po
Mm.
yung test po na gagamitin po dun, and possible po yun po, yung kumbaga malalaman po yung connection po dun sa na-measure po yung, temperature dun po sa distance na mini-measure po niyo, yun po.
Okay. Um, Devise my distance against the I thing. I'm gonna measure. Um, I can think of the test na outside of my head. Actually, ang unang lumabas sa isip ko is like, oh, may correlation ba ang distance with the temperature itself? You know, like if kasi are we like ito tanong ko. Yung mini-measure mo na temperature, like yung item na mini-measure mo yung temperature at, does it exhibit the constant temperature? Like fixed yung temperature nun?
Opo, fix pa rin
Okay.
po. Pero yun, 'pag po niyo po niya siya, nagiging iba na po. Yun po, like
Ah,
para paano po malaman kung, yung maximum distance na,
Allowable.
accurate pa rin po yung
Got you. Yes. So one aspect is like it's not the final answer, but like one aspect is you would want to do a correlation, and then in your correlation, so your Pearson R correlation would take the distance and the measured temperature. And then pag isa-scatter plot mo siya, makikita mo parang may trend line. So distance, let's say, as your x-axis, and then temperature as your y-axis. And then ideally, dapat nga yung makikita mo, the y-axis should be a flat line. Like dapat at any distance, dapat yung y-axis mo flat line, di ba? But if your observation now becomes more of like a 45-degree angle line, then there's a correlation between the distance and the measured. Now, ang tanong, ang next question there, after just conducting like this correlation is, at what distance is it still acceptable yung temperature? So, you would do repeated measurements, right, for specific distances. And then, post that, you will have to compute for a confidence interval for a specific set of distance. Let's say you have 3 distances that you have in mind now. Nasusundan mo ba ako? Medyo blabbery ang... So, yeah, let's simplify this. So, let's say, ngayon, may 3 distances tayo. 1 meter, 2 meter, and then 3 meters. For the 1 meter, i-measure natin yung temperature 10 times. For the 2 meters, i-measure natin yung temperature 10 times. 3 meters, ganun ulit. Ngayon, the first thing you can do is the correlation. So, 1, 2, and 3 meters, what's the temperature? Anong itsura ng plot? Anong itsura ng scatter plot? Pag may nakikita na kayong pattern na pag mas malayo, mas bumababa yung temperature, then that's kind of like another recommendation that you guys would like have to write to, or another observation that you guys can write to. Now, post the correlation, you will have to conduct kind of like from the 10 samples on 1 meter, you would get a confidence interval, and you need to make sure that the confidence interval is still above or is still passing your limit. So let's say on 1 meter, yung confidence interval mo is between 36 to 38 degrees. And your minimum limit is, let's say, 36 degrees. So pumasa yung 1 meter, di ba? Kasi yung confidence interval mo nasa 36 to 38. And you're only expecting that the temperature should be specifically 36 or more. Oh wait, sorry. Constant pala yung temperature, no? Actually, if there's a deviation from the 36, what's the allowable deviation? Confidence interval. Di ko na ma-visualize pero what I would say is, one, you could do confidence intervals first, and then from the confidence intervals, you would have to compute kind of like an independent sample and see if like your 36 is significantly different from like a 36.7, something like that, from your confidence interval. Yeah, I will have to take a look at this. Like medyo vague yung sagot ko sa tanong mo eh. So I'm not even convinced of my answer. Let's take this offline. I will have to take a second look.
Okay po. Thank you po, sir.
Yeah, yeah, yeah. Let's take this offline kasi I feel like there should be like a different test altogether. Yung binigay ko medyo vague pa na sagot eh. I, even I'm not convinced of it. So yeah. Any more questions?
Hello po. Um, ayos lang po ba na i-modify po yung test na gagamitin para sakto po siya ah, sa ina-analyze niyo pong data? Halimbawa po, yung t-test po, 'di ba po, usually ang null hypothesis po natin doon is yung there's no significant difference, gano'n. Then, ayos lang
Right.
po ba na i-modify siya, like yung babaliktarin niyo po yung comparison doon sa critical value para po pasok siya. Halimbawa po,
Ah,
'di ba po, madalas po kasi na kinukuha nating test is mas better po ba siya dun sa dati or alin yung mas
right,
maganda.
right.
Pero meron din po kasing test na gusto mo parehas lang po yung kakalabasan.
Right. Yes, yes, yes. Hindi ko wait lang. Hindi ko alam kung saan nakuha tong general notion that I don't know. Even I'm like kind of like sucked into this general notion that a null hypothesis should always be greater than or equal to a specific value, whatnot. But yes, the straight answer is as long as your null and alternative hypothesis is encompassing, which means it covers all possible scenarios. So if your if your null hypothesis you say that this value is greater than this value, then your alternative would be equal to or less, correct? If your null hypothesis is less than, then your alternative would be greater than or equal to. If your null hypothesis is equal or there is no significant difference, then your hypothesis alternative would be there is a significant difference. So okay lang as long as you properly state your null and your alternative to actually fully cover all possible scenarios. So the possible scenarios would only be on those three sets. So greater than, null hypothesis is greater than, alternative would be less than or equal to. Null hypothesis is less than, alternative would be greater than or equal to. Null hypothesis is equal, or null hypothesis is not equal, alternative would be equal, something like that. So okay lang, as in like there's not really like a hard like there's no restriction, if I may say that as a term. Maybe it's just like a general research convention. I don't know. Like John might have like a second comment on this one in terms of the null and alternative hypothesis, because I'm looking at it at a perspective of a stat, like just data science itself. In research, the general convention might be that like your null hypothesis should be something around like the greater than or equal to whatnot. But in the general convention, what we care about is that when we define null and alternative, we cover all possible scenarios. So what you were saying as like, okay lang bang baliktarin? Yes, as long as you cover all possible scenarios.
Yeah, I also
Thank you po.
agree with that.
So, based on your experience ba, John, like may mga research ba na binabaliktad?
Usually sa akin kasi medyo ano eh, I don't
Or like
usually,
just equal to or not equal to, something like that?
yeah, mostly like that. Mostly like that.
Mostly like that, diba?
Mm-mm.
Yeah.
Especially if you're like in the like hard sciences, like plant responses, agronomic traits, it's
Yeah.
usually like that. So I think what he Kenneth is trying to ask is like it's more of more of like in the quality, not actually qualitative, but more of
Applied,
apply. Yeah, something like that.
mga applied sciences. Maybe sa applied sciences, yeah. I don't, yeah. In statistical standpoint, like it's not actually wrong.
Yeah,
It's valid.
it's really valid. It's really valid actually.
It's really valid. Yeah. Yeah, yun yung sagot.
You
Another thing, maybe I just
mhm.
want to point out and maybe, sorry, go ahead, John.
No, no, no. It's okay. It's okay. Continue.
Yeah. So another thing that I would want to point out, and maybe there's no research that's actually tackling that here, or like there's no one from from a specific research. There are some research that you cannot actually conduct a statistical test altogether.
Yes.
That's because, let's say my research is creating a new software. I cannot do a statistical. I cannot like for my like broadest sense, I cannot do a statistical test on that one.
Mhm.
What I can do are other forms of tests, like a usability test, how usable it is to the user, how accessible are the keys or whatnot. So those are softwares. That's just an example, like wherein statistical tests might not be the best fit. So not all researchers are made equal, basically.
Yep, that is true.
Yeah.
So guys, do you have more questions for John Elmer? Oh, okay. So we have we've had like a really good discussion about this. So anyway, if you guys still have more questions about data gathering and analysis, our Facebook group is open, so
Yeah.
you can actually message John Elmer regarding this.